All right, thiols have this sulfur hydrogen group on it. It's like an alcohol, but it's with the sulfur. Thio, so remember I talked about mercapto. Mercapto implies a sulfur. So does a thio. Okay, if you see the word thio, that implies a sulfur. Now thiols it's like an alcohol, but with the sulfur. That's why you have this OL here, like alcohol. But the thio part is the sulfur part. Okay. So naming these ethane thiol, you just put a thiol at the end of it. Okay, they are just like ethers in every way. They are bent. They are 109.5. They do a lot of the same chemistry as alcohols do. Okay, however, you do not have a hydrogen bond. Sulfur, very hard to form hydrogen bondings. They can form very, very weak hydrogen bonds. So you really can't form a hydrogen bond with them. They have very low boiling and melting points, again, compared to alcohols. So here's an example of an alcohol to a thiol. We're talking a difference of, what, 43 degrees here, all right, almost half. All right, the IUPAC, I'm not really going to hold you to, I'm not going to hold you that responsible for naming thiols, but basically you name the alkane and then put thiol at the end. So methane thiol, 1-propane thiol. All right, so it's the name of the alkane followed by thiol. Okay, characteristics, they have a stinky, stinky smell to it. Skunk, onions, eggs. All right, you know the yolk in eggs are yellow, and sulfur is a yellow solid. If you actually isolate, if you actually find, if you go to like the sulfur mines, it's this yellow solid that kind of has a rotten eggy smell. That's because eggs have quite a bit of sulfur in it. They can be oxidized to what's called a disulfide, particular a disulfide bridge or bond. So if you take two thiols, so you take two of them, all right, so you take an SH and another SH, and you oxidize it, what happens is you lose the hydrogens and the two sulfurs bond to each other. So you kind of get what's called a disulfide bond. In biochemistry, they call it a bridge, a disulfide bridge. Hair does this a lot. The more of these you have, the more curly your hair. Okay, so for people that just have naturally curly hair, it's because you have a lot of these disulfide bridges. All right, there's an amino acid that actually has a thiol on it. And what basically it is in your genes, when you produce the protein of your hair, they code for a lot of these amino acids that have an SH in it. And these SHs get oxidized and they start forming these linkages and you have curly hair. And in fact, I believe in here they talk about how a perm works, which I believe that we'll talk about in a second. You can get rid of these by adding a reducing agent. So you're doing the opposite of oxidizing. Rather than removing hydrogen, you're adding hydrogen. So if you want to straighten your hair, they have a lot of chemicals. So for people that have curly hair and they want to straighten their hair, you can actually take chemicals, which is a reducing agent, put it in your hair, and you can actually start breaking some of these bonds. And here's kind of how a perm works, or how curly hair works. All right, basically how a perm works is if you have straight hair, you might still have these bonds, but what happens is that there are two chemicals that you put in the hair in order to get a perm. The first one breaks every single sulfur-sulfur bridge, and it reduces it. Okay, I think it's called a relaxant, I believe. Then what they do is they crinkle your hair, or they put in curlers or whatever. Then they add an oxidizing agent, which stinks really bad. And the oxidizing agent then starts reconnecting these sulfurs, but they don't reconnect it how it originally did it. It starts connecting them within the hair strands, and it causes them to actually all kink. And that's kind of how you have a perm. And I believe the more of this you use and the more of this of that you have, the tighter your perm. And the less of it you have, the less of a perm you have. So that's basically the chemistry of perms. It's basically breaking all of these sulfur-sulfur dye bridges, and then it's reforming them, but once you've crinkled the hair in a way so that it makes these bonds. All right, obviously you have to get a perm done ever so often because your natural hair starts growing back and it grows back how it originally is all coated. All right, and then you have to go in and do this. Also, over time, as you wash your hair and sunlight and things like that, it will break these bonds eventually and reform them back into here. So with shampoos and soaps and sunlight and stuff like that, eventually the perm will go away and reform back to its to like a natural state. Okay, so hair is then turned around curlers and an oxidizing agent is applied. This reforms the disulfide bridges in the hair, now giving it a curly appearance. All right. Um, a lot of people also ask me, well, how about when I straighten my hair? Like, let's say I don't do a perm, I take a shower and my hair is completely wet, and then I take a flat iron, and then I put the flat iron in my hair. What you're doing there is you're changing all of the hydrogen bonds in your hair, because when you retake a shower, your hair goes back to exactly how it was. Because what you're doing is when you are taking a shower, you're putting all these water molecules in your hair, and you're breaking up all the hydrogen bonding in your natural hair because it's now hydrogen bonding with the water. When you put the curler on, what you do is you are immediately evaporating all that water, and you're reforming new hydrogen bonds in your hair where it's more of a straighter appearance, like what we have here. So you reform the hydrogen bonds, you evaporate the water so it stays straight. But then as soon as you get your hair wet again, it goes back to its normal state because the water now is infused, it breaks all those hydrogen bonds you formed, and then as your hair naturally dries and the water evaporates, those hydrogen bonds reform in the way that your proteins have been all synthesized and how it normally is. So probably more about hair chemistry than you want to know, but I bet you didn't realize how much chemistry there is involved in hair. It's just kind of interesting. All right, so there you go. That is chapter 14, and I will see you in next class.